Wave optics, coherent source. The source which emits a light wave with same frequency, wavelength and phase or having a constant phase difference is called a coherent source. Incoherent source. An incoherent source emits a light wave having a different frequency, wavelength and phase. Two independent sources can't be coherent because light is emitted by individual atoms and not by the bulk of matter acting as a whole. Even a thinnest source consists of millions of atoms and emission of light by them takes place independently. And third point, even an atom emits an unknown wave of about 10 power minus 8 second due to its transition from a higher energy state to a lower energy state. Conditions for obtaining two coherent sources of light. The first one, the two sources of light must be obtained from a single source. Second point, the two sources must be monochromatic, that is of same color, and the path difference between the light waves from the two sources must be small. Now let's consider some questions. Two plane monochromatic waves propagating in the same direction with the amplitudes A and 2A and differing in phase by pi by 3 superimposed. Calculate the amplitude of the resulting wave. So we have A1 as A and A2 as 2A and phase difference phi is pi by 3. And we know that A square equal to A1 square plus A2 square plus twice of A1 A2 cos phi. We can put the values. So it will be A square plus 4A square plus 4A square cos pi by 3. And cos pi by 3 is 1 by 2. So this will become A square plus 4A square plus 2A square. That is 7A square. And this is A resultant. So A resultant equal to root of 7A square, which will be A root 7, which is our answer. Now consider next question. Next question says, in Young's double slit experiment, the intensity of light at a point on the screen where the path difference is lambda is k units. Find the intensity at a point where the path difference is lambda by 4, lambda by 3, and lambda by 2. So we know that intensity I is given by I1 plus I2 plus twice of root I1 I2 cos phi. Here, if we assume that I0 be the intensity of either source, then I1 equal to I2 can be written as I0. So this will become I0 plus I0 plus 2I0 cos phi. So this will become 2I0. So 2I0 can be taken common. 1 plus cos phi will be left. And if you remember the formula of cos 2 theta, that gives 2 cos square theta minus 1. If we replace theta by 2, so it will become cos theta will be equal to 2 cos square theta by 2 minus 1. So here in place of cos phi, if we write 2 cos square phi by 2 minus 1, then 1 will get cancelled. So we will get I equal to 2I0 and 1 plus 2 cos square pi by 2 minus 1. So 1 will cancel out, and we will get 4 I0 times cos square pi by 2. Now, in our question, it is given when the path difference is lambda, then intensity is k unit. So we can say P equal to lambda, then pi corresponding to lambda will be 2 pi, because this is lambda and this is 0, this is pi, this is 2 pi. So pi corresponds to 2 pi. So if we put this value here, so in place of I, it is given as k. So k equal to, in place of I am writing k, 4 I0 times cos square 2 pi. So divided by 2, because it is 5 by 2. So divided by 2 will become cos square pi, and cos pi equals minus 1. So cos square pi will give 1. So k equal to 4 I0 times 1. From where we can get, so this is value of, from here it gives value of I0 as, so this will give I0 equal to k by 4. Now, case 1, when path difference is lambda by 4. In that case, pi will become 2 pi by 4, that is pi by 2. For lambda, it is 2 pi. So for lambda by 4, pi will be, this is value of pi, this is wavelength. So 2 pi divided by 4 will give pi by 2. So again, we put the value. So it will be I equal to 4 I0 times cos square, and here if we put in place of pi as pi by 2, so we will get pi by 4. And cos pi by 4 is 1 by root 2, so square of it will give 1 by 2. So 4 I0 times 1 by 2, that is 2 I0. And we have I0 equal to k by 4. So I corresponding to this value will be twice of k by 4, that is k by 2. Now consider third case, sorry, second case. In case of second case, it is given that when path difference is lambda by 3. So we know that lambda corresponds to 2 pi. Then lambda by 3 will corresponds to 2 pi by 3. Now intensity equal to 4 I0 times cos square pi by 2. So we put the values, 4 I0 times cos square pi. Pi is 2 pi by 3. So 2 pi by 6 or pi by 3. And cos pi by 3 is 1 by 2. So from here we will get intensity equal to 4 I0 into 1 by 4. So that will give I0. So we can say that intensity this time is I equal to, we have got it as I0, and I0 is K by 4. Now consider last case. Here path difference is given as lambda by 2, and we know that lambda corresponds to 2 pi, then lambda by 2 will corresponds to pi. So again we find the intensity. Intensity I is equal to 4 I0 and cos square pi by 2. We put this value here. So 4 I0 times cos square pi by 2. And we know cos pi by 2 is 0. So intensity will be 0 this time. Thank you for watching.